YouTube, welcome to this next installment of the Evian blog. So today I thought, well, hey, let's have a look at some of the projects that I've been working on. There's been a few. One of them is for a local hardware supply chain. They're looking for backup lighting systems, LED, for load shedding. So basically here in South Africa we have something called load shedding, where the power utility turns off the power in various areas for 2-hour increments, allowing the grid to supply the rest of the users during that time with full power basically. So what they've decided now is to do this on a almost permanent basis. As soon as the grid becomes a little bit under load or overutilized, they turn off specific areas at specific times so that it sheds the load basically. So the load is spread out. And yeah, it's basically what that means is that different areas are off for 2 hours at a time, up to 2 hours at a time. Which is a bit of an inconvenience for many. So what I've been doing is looking at various solutions like inverters, solar energy and stuff like that. I've been installing these systems in people's homes, etc. But also for those of you that don't have the money to go out and purchase a solar power system or a generator or any of those such systems, I've also designed some fairly simple solutions such as backup lighting systems, where when the power goes off, you have secondary lighting in the house which turns on. These are both portable or fixed, depending how you'd like to look at it. Most of them make use of various different technologies, but what I'm going to show you guys today is something that's relatively cheap to put together and does work pretty well for a backup lighting solution. Many of you may still have gas or camping gear where you can still cook, etc. But this takes care of your lighting needs during load shedding times, and the build of the device is possibly less than about 200 Rand if you shop wisely. Call it 300 Rand with the battery and LED bar. So let's take a look at that and see what it's all about. Alright. So what we're looking at here is pretty much the bulk of the system, including the light tube down here. So what happens in this circumstance is the unit is plugged in. This is basically a power supply on the bench emulating a pre-configured charging power supply, which is now charging the batteries. We've got a green LED showing us that the battery is on charge. We've got AC power, etc. The battery is currently charging at a rate of about 13.4 volts. You can set that up however you like, but let's simulate a power outage by switching off the DC power supply. So, besides the blinding light, the one thing you'll notice is the LED changes to red, indicating that we are now in a backup. There's no AC power. The LED lighting switches on is running off this battery. As soon as the power comes back on, the light will go back into a charge state. To charge the battery, the light turns off, and obviously your standard AC home lighting kicks in. What is this thing made out of? Well, let's get in closer and I'll show you guys. First and foremost, we have our battery. This is a standard 8 amp hour or 7 amp hour 12 volt 13.8 volt gel cell battery, as they call them, which is then connected to a rather small, there it is there, relay. The relay outputs basically, this input over here is basically sensing charge voltage coming in from the charge power supply, going to the battery, powering it on green, and then obviously when the power goes off over here, the power from the battery comes into the relay over here, passes through to this contact here out to the light, and then also energizes the red section while the green section turns off. So basically what that means is we have, let me just move the lighting so it doesn't interfere with the LED. Green, we've got AC power. Red, we've got DC battery running off battery. So pretty much that's how that works out. Now, the first thing you're going to ask me is how come this signal over here, the voltage doesn't come back down, you're keeping the green LED on, or, you know, just creating a bit of havoc? Quite simply because this line over here is a one-way. So basically the signal can go up, it goes through, which you can't really see because I've put some tape, some heat shrink over it. Inside here is a rectifier or diode, which is allowing the signal to come in through one way to charge only. The output cannot come back down that line, it can only come down through the relay, energizing that output over there. So that just basically gets rid of one of the small problems which you would have with such a system. Now, just to show you guys, right now the battery is on charge. As soon as I turn off the power supply, the backup lighting comes on, and obviously now we are running off the 7 amp hour 12 volt gel cell battery. As soon as we come back on, you'll see the current needle will pick up because the battery will take an initial bit of charge. It's not flat, so it's not going to be a lot, and it'll just boost itself back up there, just to give you an idea. So the next step of this project will be for me to build a proper sort of power supply come charge circuit, bearing in mind that diode which is dropping you by 0.5 to 0.7 volts. So we possibly need something in the 14.5 volt range to get our charge voltages that we require to charge our battery properly. Technically you could use it like this, just off a nice sort of 1 or 2 amp power supply to charge the battery. Should you do it? Yeah, I suppose you could if you're not too worried about longevity of the battery. You'll probably get a year or two out of it before the battery starts giving you nonsense, but the correct way to do it, of course, would be to build a proper charge circuit. So for now, what I'm going to do is purchase a pre-made gel cell power supply charge circuit, which is variable, which allows me just to push the voltage up a little bit higher than the charge voltage due to that diode. We're needing to get past that diode's voltage drop, and yeah, pretty much that's it for a very simple, very basic but functional backup lighting system for your home. Hey everybody, to put it in simple terms, I'm going to show you guys here on the whiteboard how this little spider thing over here does its job of powering up off the backup battery on power failure. It's a very simple, very basic idea. So excuse the simplicity of it, but it does work. Let's get in a little bit closer and take a look. What we have here is the basis of the circuit. You've got your charge 12 volts over here, which is powered from your AC mains. So as long as there's AC mains, there'll be a charge voltage coming in over here, which energizes the relay, turning the relay on, or disconnecting the normally closed, so that the normally open contact is connected now with a common contact. Why? Because the battery we don't want to be going through to the lighting at the moment. We have power, we have our normal AC lights on, so there's no need for the battery to be powering. The battery now pretty much sits on charge. If you look, we've got a direct connection from the positive power supply through this diode over here, which only allows the voltage to travel through, or the current to travel through in one direction, and then we've got our negative also to the battery. So the battery is on charge as long as there's power over here. As soon as this power goes off, what's going to happen here? Firstly, the charge voltage is no longer going to be flowing to the battery, so the voltage cannot go through this diode over here, so it's pretty much going to hit there and it's going to be at a brick wall. So it's all going to be potentially put through to this normally closed, which is now going to be closed again because the relay is de-energized. So now this normally closed connects to the common rail, basically completing the circuit and allowing the battery to power the light. That's pretty much as simple as it gets, ladies and gents. It doesn't get any simpler than that. Now, there's a few things you could do. Okay, I know this is not the symbol for an LED, but it's just for illustrative purposes. You guys get the gist of it. And now we have a pen going dry. Always a lot of fun, isn't it? But anyway, you get the gist of how this functions. It's a very simple solution to a common problem here in South Africa. So basically this will charge, bearing in mind we've got a 0.5 to 0.7 volt drop over here through this LED. So this charge voltage needs to be sufficient to get enough power through to the battery for the battery to sufficiently charge. What I recommend is some sort of a smart charge system which also monitors, but obviously the diode could get in the way with that over there. So for keeping it basic, we're just going to use a standard sort of about a 14.5 volt supply over here, which will mass charge the battery. The battery might not last as long as what it would with a proper charger, but it'll get the job done of what you guys are wanting to do in the meantime. Power's on, relay's energized, so these 2 points are connected, lights are turned off. Battery is charging through the diode from the charge voltage. As soon as the power goes off, relay switches off, normally closed and common make a connection. Battery current now flows through the LED lighting and basically powers up the lighting as long as the power remains off. Now what you guys saw with the LED on there, all I've pretty much done is I have set it up in such a way that one LED is monitoring the common point here, the other LED positive is monitoring the positive charge in, and then the negative signal, which is common throughout, has a current limiting resistor, allowing only one of the two LED portions to be turned on at a time. Very simple, just a little 1K resistor or whatever the case may be, just to limit the currents a little bit. And that's pretty much boils down to the basis of how this extremely simple circuit actually works. All it basically is one diode and a double throw single pole or single pole double throw relay, and obviously something to charge your battery, and of course you need one of these 7 amp hour batteries. That's it, guys. I hope that helps you a little bit with setting up your own basics emergency lighting at home. I will share with you guys my professional level emergency lighting, which is microcontroller controlled at a later stage, but for now, that's it. Get building.